Welcome to the last lecture of this module, that is actuators, sensors and safe workspaces. Okay, in this lecture we will confine ourselves to industrial field bus, drives and devices, safe workspaces, safety triggers, workspace monitoring and marking forbidden zones. Specifically, we will be discussing on industrial systems that covers field bus, CPU, couplers, drives and systems. We will discuss on workspace and operator safety and various important terminologies which will cover them all. Okay. So, let us start with industrial systems, starting with the field bus. What are field bus actually? Field bus are industrial digital communication system that are implemented through network hardware and software protocol for safe, reliable and real time distributed control, that is most widely used in the industry, and the transmission can be as long as a kilometer at times. Okay. So, that distance can be very long and it can be on board systems also. Let us say you have a joint sensor and you have a controller, both can communicate with each other using such field buses. So, these are standardized by International Electrotechnical Commission IEC 61784 and 61158. Okay. Starting with the first one, that is Ethernet or IP based protocol, that is Control Net International Limited. In 1990 they come up with this idea, and this was Common Industrial Protocol CIP to Standard Ethernet. The Standard Ethernet is the one that we are using in our desktop PC or a laptop also. This is meant for industrial systems. Leading in the US and 30% of share internationally was there, and it was managed by Open Device Net Vendor Association, ODVA. Okay. But this didn't lasted longer because of some safety concerns and its performance. Profibus is the common name for Process Field Bus. Profibus. It was promoted by BMRF, that is the German Department of Education and Research, in 1989, and later it was largely used by Siemens. Siemens, you know, is a very good manufacturer for motor, actuators, drive systems, PLCs and many more. Okay. So, they have come up with Profibus and most of their Siemens systems uses Profibus. DeviceNet is the next one, which is given by American company, that is Allen Bradley. Allen Bradley again is now known as Rockwell Automation. They make PLCs, again they also make various other input output cards, drive systems. Okay. So, DeviceNet is an application layer over CAN bus system, controller area network, that was come up with Bosch initially. Okay. And adapts the CIP. CIP is the Common Industrial Protocol. It adapts that, and this again is managed by ODVA, Open Device Net Vendors Association, ODVA. They are robust as compared to RS-485. RS-485 was earlier days, it was a serial protocol and it became very popular because of its simplicity, but it has many safety concerns and security concerns also. So, that is the reason it was modified and adapted as different other forms. Now comes the Modbus. It was given by Modicon in 1979. Most widely used versions of Modbus are serial RTU, TCP IP, UDP, MB plus, etc. It has many limitations, like large binary format is not supported. So, that is the reason it can handle addresses up to 247 devices only, and it lacks security. Unauthorized commands can be given and interceptions cannot be checked. So, this is the reason, because of safety, security and limitations in its format, it is limited, but yes, still it is most widely used in the industry because of its simplicity. This protocol is very popular. Next one is OPC UA, that is Open Platform Communication. This is open, this is not a proprietary format. It is a unified architecture for cross platform communication. It is open source also, which is governed by IEC 62541 standard, and supports data exchange from sensors to cloud applications, that is developed by OPC Foundation. Okay. So, this is one of the most advanced one, that is the newer one, that is an open source also. It is not a proprietary format. This can be it would take some time to become very popular. It is this one. So, these symbols are for these standard formats. Those are just like logo and registered trademarks. They are used for different communication modes. Here EtherCAT is basically Ethernet for control, automation and technology, Ethernet and CAT. Okay, this is for Ethernet based field bus system. It was proprietary of Beckhoff. Now they have revealed the technology to the world, and quite lot of adaptation of EtherCAT technology is there in multiple devices, even by Siemens and Allen Bradley and many other manufacturers. That is standardized by IEC 61158, both in hard and soft real time. The beauty of this is it supports wide range of devices and with a very small cycle time. You see, cycle time is less than 100 microseconds. It goes very, so that is the reason it can communicate in gigahertz. Okay, they are very fast. Okay, not just fast, that is secure, and now because of wide adaptation it is very popular as well, and most commonly used in the cobot also for controlling its servo drives, for communicating with the sensors which it has. Okay. So, now what are system that is also very popular to industrial systems, mostly for robots. Robots doesn't use a standard PC like our desktop or a laptop. They are ruggedized PC, which is known as industrial controller or a CPU. They are just like standard computer, but it has quite good amount of safeties, and they are ruggedized to be used in a rugged environment like industry. See, the processors looks quite old, but that is quite good enough to do real time communications and to run the standalone programs that is dedicated only for the robot. Okay. So, it is just one of the configuration that I have put. There are many such industrial controller. I have just chosen one to demonstrate you. Okay. So, you see it has standard RAM, DDR4 RAM, SD card, 40 GB of flash, which can have the operating system like Windows embedded. 24-volt power supply can be used. 4 USB ports to take in the pen drives and data. Display output ports are there to connect to the external displays. Ruggedized aluminum zinc die-cast housing. So, it is very much ruggedized. It can take up quite good amount of load also, unlike our laptop or a desktop. Various mounting options are there. It can be mounted on DIN rail, it can be mounted on cabinet within the controller of the robot. It has a TwinCAT real-time Ethernet, so that is EtherCAT maybe. On Windows IoT, that is CE, multi-touch FHD, full HD monitor may be fitted. It can take up that, which may be used as a HMI for visualization and interfacing. Okay. So, you can use 120 watt 24 volt SMPS with battery backup, just like a standard UPS, to supply this kind of CPUs. Okay. This is an EtherCAT coupler. Basically, when you are doing all the robot kinematics in your computer, you have to transmit all the joint angles to the servo drives. So, that can happen in multiple ways. You can use devices like this. So, you provide this standard Ethernet with 1 gigahertz or higher frequency can be converted to EtherCAT, that can be used like an EtherCAT. EtherCAT is a software protocol in that case. So, using that protocol you can communicate to this device. This in turn can connect multiple cards after this. Okay. So, it can take up an EtherCAT signal in, and it can connect other similar devices from this output also. Okay. They can be daisy chained, I will show you, or you can take in the input to EtherCAT terminal over here, and you can have multiple such connections over here, just like a switch, any standard Ethernet switch. Okay, so it looks like this. So these are the parameters. It has two RJ45 socket, 100 meters, you see, with Cat5 cable it can take up such a long distance data. Number of terminals which can be connected after this ranges up to 65535. Okay. Further, EtherCAT extension is also possible. So each such device can connect to 65535, and then after this you can connect one more of this and connect another 65535 devices. You see, a huge amount of IO cards and data cards, motor drives, and such EtherCAT supported drives can be connected to this. A similar one is possible even with Modbus coupler also. I have shown only the EtherCAT coupler. It can be a device net coupler which would look very much similar to this. This additionally may require a surge filter which is attached to protect from over voltage, lightning load, okay, any dynamic disturbance if it is there in the power supply, so as to protect this device. Okay. Next comes a motion controller, okay, a motion BLDC motion interface. This interface can be clubbed after this. So this can come here, okay, on the DIN rail. So this again is a DIN rail supported one. So this is just a BLDC motion interface. It can run with 48 volt DC, okay, 4.5 ampere. So this is the maximum capacity this can handle with a PWM clock frequency up to 16 kilohertz. So yes, you see it has various connections to connect your BLDC motor. So this is for Hall effect sensor, Hall effect sensor, Hall effect sensor, and motor phase wire U, V and W goes here. Motor brake supply can be given from here. This is 48 volt supply, that is for the motor. Fan supply is here. Fan may be connected over here so as to cool it, okay, and encoder feedback is fed here. So this itself is a hardware which has all the closed loops, okay. Then it needs the data from the EtherCAT coupler which further transmits it to this to communicate the desired joint angle, position, velocity, torque, okay. So accordingly it can create multiple closed loops depending on the configuration. Communication protocol EtherCAT, soft real time using TwinCAT interface is required for this, and an Ethernet card of 1 gigahertz is to be used with this. Programming can be done using API, that is TwinCAT ADS library, which supports Python. It supports various other programming languages also like Visual Studio and all, okay, may be used to access the motor runtime variables to control speed, position and torque. So you need to do everything in your computer, transmit the data to this real time motion interface which has all the closed loops, high frequency closed loop to control your motor. So now with a motor it can be clubbed. So motor may look like this, okay. This is a simple BLDC motor with so many wires. So it has wires for Hall effect sensors, it has wires too for the three phases here to supply this three phase to this motor, okay. This is a open frame motor, so it can be embedded inside the joint also. So these are the parameters. Parameters has almost everything that is required to control it. We will discuss various other parameters which are necessary to control such device. Few of them are mechanical and electrical time constants, back EMF constant, rotor inertia, resistance and the inductance of the coil which is here, okay. And rated current, maximum current that can pass through this is 3.3 ampere. Maximum torque that it can handle is 1.2 Newton meter, okay, and the rated torque is 0.6. So accordingly, see torque constant, which is again very important. With using this, you can control the torque if you can control the current. So the EtherCAT coupler finally couples all the cards that goes here. So all the card comes here like this. So this is what is the first one. You see, you have the CPU. Next one is the EtherCAT coupler, and then you have all the cards that are attached one after the other. Next, okay, finally the servo drive. It can be an external servo drive. So everything else can be connected in a daisy chain manner, the way it is shown in this figure. Okay, so this is how all the cards like this BLDC servo motor motion interface, it comes here. Okay, even the all the cards that are shown here, they are clubbed one after the other. They are packed together in a manner like this, as I have shown here. The first thing is your IPC, that is industrial PC. Next one is your EtherCAT coupler. Third one is power filter device, and then comes the other input output card and the servo motor drives. Okay, so everything else, so that can go there. Altogether, one EtherCAT coupler supports 65535 such cards. So overall the layout may look like this. So this is your CPU, the one that I have shown. This is the UPS to maintain a constant supply to this CPU and other devices. This is EtherCAT coupler, this is the power surge protection device, and here comes your BLDC motor driver, and all the connections are shown here. That includes motor phase wires UVW and the Hall effect sensor wires. So if the motor has a brake wire also, so this servo drive also supports that. Similar is an arrangement for permanent magnet synchronous machine, that is PMSM motor, also AC servo motor motion interface. In this case it looks like this. When you have UVW for the phases, brake inputs, and you also have the feedback input from here, that may be a resolver or some kind of that. Okay, so it can give you, take up the data for the feedback and create the closed loop. Okay, this is the supply for the PMSM system. So this is basically a variable frequency drive maybe. This again needs to be connected with a similar EtherCAT coupler, because this is a EtherCAT device again which communicates via eBus. So important parameters are here with which you can control your motor. Okay. So again a standard motor looks like this. This uses a single cable for data as well as power, UVW as well as encoder values, both are running from a single cable. So this is a permanent magnet excited 3-phase, standstill current is given. So with that you can choose the appropriate servo motor drive for this to run this. So maximum peak torque is this, rated power, maximum running voltage, feedback is multi-turn 18-bit. So you may have some kind of encoder which is here. Rotor moment of inertia, it is required to precisely control such motor. Programming requires again TwinCAT configuration, TwinCAT ADS library with Python to access the motor runtime variable. Okay, that needs to be done with the drive that is shown here. Okay, this is now can be connected like this. So here comes your AC servo motor drive, which is here, surge protector, EtherCAT coupler, power supply for 24-volt, continued power supply for using UPS, and this is the CPU and a HMI. Okay, so this may be a typical system to control such AC servo motor. Now let us go to workspace and operator safety. I had just introduced you to the workspace and operator safety here. Industrial cobots are built with best in technology available with the recognized safeties. Okay, unlike academic setup may use a setup of cobot which may not be that rugged, and it is not safe to be used in industry with people all around. The intended purpose is clearly defined in the robot's technical data sheet. if it is to be used for pick and place or for hand guiding or maybe machine tending. So, a specific application is precisely given in the robots technical data sheet. Impermissible misuse, that includes robot for transportation, for climbing, in outdoor operations, right? Potentially explosive environment without any safeguards. So, these are not recommended, and this is not an exhaustive list. There may be many such cases when it is not permissible by the manufacturer to be used. Okay. It should be used only by the trained personnel and in accordance with the guidelines provided by the manufacturer. Normally, training is to be given beforehand. Any planned maintenance or breakdown should be attended immediately by the authorized trained personnel only. Anybody cannot do any modification to the hardware or to the program also. Okay. Any robot handling tasks are clearly distributed to the operator, programmer and the system integrator. Okay. Operator is the one who is actually on the assembly line or anywhere, who actually uses it. Programmer jobs are done once the robot is put to use and handed over to the operator. Integrator basically does all the hardware job and configures the system to be used by the operator and the programmer. Okay. Any modification to the structure of the robot is to be authorized by the manufacturer. You are not supposed to do any modification to the structure of the robot as well. Okay. Apart from just changing the tool end, which is documented in their manual also. Please note, manufacturers do not guarantee that the cobot will not cause any personal injury or material damage even after all the safety instructions are followed. So, application to application it depends quite a lot. So, manufacturer do not guarantee such injuries if it is caused due to the mishandling or misuse of such robots. So, yes, conformity to the directives published by European Agency for Safety and Health at Work, BIS and ISI. Let us talk about that. Any cobot constitutes partly completed machinery as defined by the EC machine directive. It is just a partly completed machinery. It is not a complete machine. It has to be integrated with accessories, maybe a conveyor, maybe turntable or maybe linear rail or some other accessories, gripper, force sensor. So, it includes a lot of other peripherals. So, as per EC machine directive, it is a partly completed machinery only. The cobot is integrated into the complete system together with other machinery constitutes the complete system. Okay. Safety functions and safeguards are required. Robot in itself is not very safe, okay, even if it is a cobot. So, it also needs some kind of safeguards for operation, which is added and defined by EC machine directive. Now, the compliance to EC machine directive needs to be confirmed by means of assessment of conformity. This forms the basis for the CE mark for the system. If you remember CE mark, it looks like this. Okay, this is very popular mark which is quite often you must have seen even in your laptop. CE mark, that is the European community that appear on any commercial product that are traded on the extended single market of the European Economic Area EEA. Nowadays even Indian products, if they tend to sell their product to European markets, they have to conform to CE mark. In India, it is also required to comply with local standards like BIS, Bureau of Indian Standards, BIS and ISI. Now, few important terminologies which is very important for you to know before you put any robot to use. Okay. Triggers for stop reaction, stop categories as per ISO 13850, that is for the safety of machinery. What is danger zone? A robot workspace and the stopping distance. Let me just display the figure here. If you can see this figure, you see there is a zone which is marked as 1, that is the danger zone. That is for most of the time robot works in that region. That is the danger zone. It also includes the stopping distance. Okay, stopping distance is the area 2 which is marked in yellow here. So if you apply brake even in the zone 1, it can go up till zone 2. Okay, so that also is a danger zone. Stopping distance includes the reaction distance and the braking distance. As soon as you apply and brake, what will happen? It will take some time to respond, and brakes are applied, and even after applying brake, it may travel to a little distance. So this is the part of the danger zone. Safety zone is the zone outside the danger zone. That is the red region that you can see. Okay, that is where the robot physically cannot go. Okay, so that becomes the safe zone. But in case of quite a lot of cobot, nowadays it can even go behind. So that also is not very safe. Okay, even if it is a cobot, it possesses some kind of inertia and it can hit you very hard. So stop category 0. This is the stop category when the drives are deactivated immediately and the brakes are applied. The robot performs the path oriented braking. Okay, the trigger upon releasing the drives enabling switch. Drive enabling switch is the switch which is, so if you press that button, drives are released. Okay, switching off the robot, power failure. Okay, so if drive enabling switch is released, so what happens? Brake should be applied. So as long as it is pressed, it is on. Sometimes it is 3-state switch also. When it is further pressed, it is again locked. So that is known as a panic state. You hold the teach pendant, grip it softly, it will be on. Again pressing very hard will switch it off. Okay, so any of those cases, drive enabling switch goes off, encoder error, mode change, or pressing any emergency stop button on the teach pendant or on the robot or on the safety fence. Anywhere you press emergency stop, stop category 0 is executed. Stop category 1 is when the robot performs the path maintaining braking. Okay, in this case also the drives are deactivated after 1 second. That means it continues to be in its path up till 1 second and the brakes are applied. Okay, triggered upon opening the safety gate. As soon as you open the safety gate, it will gradually come to rest. It will take maybe 1 second, and till then it will maintain the path. Okay, even after pressing the emergency stop, stop category 1 may be triggered. Stop category 2, the drive remains activated. Okay, no brakes are applied. Unlike this one, brakes are applied. Even in this case, brakes are applied. In this case, it is continuously under servo. Robot maintains its position or trajectory. The robot stops with normal braking ramp. If it is a trapezoidal ramp, it will go gradually. It sometimes may be more than a second also, but it will stop ultimately. Triggered upon pressing the stop switch or releasing the start button. Now, safety oriented functions in an industrial cobot meet the following safety requirements also. So normally they are marked under category 3 performance level D in accordance with ISO 13849-1 or SIL 2 according to EN 62061. Such cobots are fault tolerant and it can detect and respond to fault within the system. Okay, that means it is less likely that they will be creating any damage in case of any single fault source. There is a new term which is only popular with cobots, especially in case of KUKA IVA I have seen, controlled robot retraction mode. Apart from the programming mode, that is T1 mode or T2 mode, that is normal execution, you do it with T2, that is the full speed. After programming you can test it, and autonomous mode when humans are not around. So there is one other mode, that is a CRR mode, controlled robot retraction mode. The robot is stopped by the safety controller for one of the following reasons. Okay, industrial robot violates an axis or Cartesian monitoring space. Axis specific motion could be, let us say you have limited your joint angle through software. Okay, in order to have some safety, you may have some object lying beyond that angle. Okay, if it violates that, then CRR mode will execute robot retraction. Okay, orientation of a safety oriented tool is outside the monitored range. Again, due to the orientation or due to the position, if it is outside the Cartesian range, you may also define a Cartesian range in the workspace where your robot is not allowed to go. Apart from fixing up the axial range where your robot should not go, you may also define it in a Cartesian space. So even if your robot goes into that region due to the orientation or maybe due to the positioning error, CRR mode is executed. Industrial robots violates a force or torque monitoring function. Okay, if it violates maximum force limitation, if you have put, robot can retract. As I have shown in one of the example, I just touch upon the robot while it was lowering and robot retracted back. Okay, so that was just a demonstration for that. A position sensor is not mastered or referenced. So without mastering, if you put the robot to use, it works under CRR mode and robot may be retracted. A joint sensor is not referenced. So all these are mastering error, okay, or referencing error, calibration error would cause this to be executed. Let us look at the robot zones. We have discussed it earlier also. Let us make it more clear here. So robot workspace, the workspace is number one over here is the workspace is safeguarded using appropriate human barriers like fences or a cage. In case of industrial robot, that is mandatory. In case of cobot, if it is put with human workspaces, with overlapping workspaces, then you need to be very careful in this region. Number two is the stopping distance, that is here. Even if you apply brake somewhere over here, okay, it can further travel to this region because it takes some time to respond, and after braking again to come to completely stop, it would take some time. So this is the stopping zone. Okay. Number three is the safety zone. So this zone is assumed to be totally safe because your physical limitation of the robot joint is exhausted here and it cannot go further. But there may be some instance in which one of the joint may take it to that space from behind. Okay, although maybe first joint cannot go there, using the second, third, fourth, fifth joint, you can still go to that region. Okay, so this still is not very safe. You may be little attentive and still be here. If you know the program execution cycle and everything else, you are basically quite safe out here. Any workspace entry gates within the safety interlocks are placed here. So normally the gates are placed here. Axis 1 may be limited using software limits to restrict the robot entering into the forbidden workspaces. So axis 1 is the first axis of the robot, that is the vertical axis. Okay, if you check this robot, it looks like this. So this is the axis 1. Okay, that is the axis 1. So that is the first axis that may be limited. So in this case, that would cause robot not to even enter somewhere over here. So you can always limit this angle. So external safeguards, that is the gates must meet the requirement of EN 953, that is safety of machinery, that is for the guards. Okay, so there is a special safety of machinery standard EN953, which decides upon the design of the gates, the type of interlocks which should be there, so it dictates everything else. Now, there are various safety functions that I have already discussed quite a lot of time, but I will just summarize them here once again. So, safety functions conform to the requirements of performance level D category 3 of the ISO 138491, that is for the safety of machinery. Time to time this year may be revised with some modifications to this. That decides the mode selection T1, T2 automatic or CRR mode that I have discussed. Operator safety, that is connected to the guards and the interlocks. Okay. Local emergency stop device on the control panel, on the teach pendant also. External emergency stop device outside the fence or the gate on the teach pendant. TP is for teach pendant. Okay, so the emergency stop on the teach pendant is an emergency stop device that is counted as external emergency stop. Enabling switch on the teach pendant for the servo motor. Enabling, as long as you don't press the enabling switch, the servos are off and the position or velocity cannot be taken up, any movement cannot be done. External enabling switch, axis specific or Cartesian specific monitoring, it governs them all. Okay, velocity monitoring for standstill monitoring, axis torque monitoring and collision detection. Okay, so all these safety functions are governed by ISO 13849-12023. Okay, local safety stop via any qualifying input. It can be a failure of any attachment which sends a feedback and that tends to stop the robot also. These functions are handled by a dedicated electronic safety control circuit within the robot controller hardware. It continuously monitors the system while the robot is on. Okay, this hardware is a dedicated one. It is apart from the main controller which executes all the programs, does the forward kinematics, inverse kinematics, everything else. Okay. Okay. Various function tests are carried out before startup and after recommissioning of such robots. Okay, so this is the summary of all the references that I have used. These are some norms and regulations which you may go through. Okay, that's all for this lecture. With this, I would end here. Okay, in the next lecture, we will start with a new module, that is transformation matrices and robot kinematics.